Sagana, and our teammates are Devika, Chandan, and Jagadish. Today's our assignment topic is burning the LED light by BJT acts as a switch. Introduction. Transistors are fundamental semiconducting components widely used to amplify, switch, and control electrical signals in electronic circuits. One of the simplest and most interactive configuration is the transistor or has a switch which forms the backbone of a digital logic and automation systems. In this circuit, a bipolar junction transistor BJT is used to control the on or off state of an LED based on the input from a push button. This experiment aims to offer practical exposure to both circuit construction and the operating principles of transistor switching, which are core concepts in electronics and embedded system design. Let us move to abstract. This experiment investigates the application of BJT as in a solid state by designing and stimulating a circuit that turns an LED on or off using a manual switch. The circuit consists of a DC volt source, a register, a push button, an NPN transistor, and an LED connected to form a classic transistor switch configuration. The push button controls the transistor's base, allowing users to observe saturation on and cutoff off modes. The study demonstrates how transistors enable automated control of higher current device using lower current signals, offering insights applicable to real-world electronics and digital logic. Next objectives. To demonstrate how a BJT can function as an electronic switch, to design and stimulate a circuit that controls an LED using the transistor and a push button. To understand transistor operating region, cutoff, saturation, and current amplification. To correlate experimental results with theoretical switching behavior in digital circuits. So next I would like to switch Chandan. Next about this methodology and conclusion.
Hello everyone, my name is Chandan. I am telling about the methodology of this circuit. First,
Video on
this
Miro.
circuit consists of ಏನಾಯ್ತು ಹಲೋ
ವಿಡಿಯೋ ಆನ್ ಇಲ್ಲ ನಿಂದು.
ಬಸ್ ಒಂದು ಸೆಕೆಂಡ್. ವಿಡಿಯೋ
ಈಗ ಬರ್ತಿದೆ ಆದ್ರ ನೀನು ಸರ್ಕ್ಯೂಟ್ ಒಳಗ್ ನಿನ್ ಮಕ ಬರ್ತಿದೆ.
ಸರ್ಕ್ಯೂಟ್ ನನ್ನ ಸ್ಕ್ರೀನ್ ಅಲ್ಲಿ ಕರೆಕ್ಟ್ ಇದೆ ಬಿಡು, ನಡೀತದೆ. ನಾನ್ ಶೇರ್ ಮಾಡ್ತಿರೋದು.
ನಡೀತೈತೆ.
ಹ್ಮ್
ಹಂಗಂದ್ರೆ ಮಾಡು.
For the first thing, assemble a circuit that consists of a 12-volt DC supply, a 1 kilo ohm base resistance R1, a push button switch S1 on NPN BJT, and an LED in series with the collector. The push button and the resistance connect to the transistor base. When passed, S1 allows a small base current which controls a large collector emitter current. In off state, no base current is present. The transistor remains in cutoff and the LED is off. When the switch is pressed, the base emitter junction receives a sufficient voltage to run the transistor on, allowing current to flow from the collector to the emitter, lighting the LED. Analyze and recording the voltage drops a current flow in both on and off states to confirm the expected operation. Ensure components are connected correctly. Parameters, example register value, are suitable for the given supply and LED rating, and obvious brightness and switching a response in simulation. Okay, the next part is the conclusion part of this circuit. Now we are going to conclude this circuit. The simulation confirms that a BJT operator efficiently has a switch for controlling an LED. When a sufficient base current is applied by the push button, the transistor enters saturation and enables current to flow through the LED, lighting it up. Otherwise, the LED remains off, corresponding to the transistor cutoff region. This experiment validates the principle that a small input current that the base control a much larger current through the collector emitter path, making a transistor vital for a digital control, logic circuits and automation takes in the electronics. This is how this circuit is built. Thank you. 5 ನಿಮಿಷ ಆಗೈತೆ ವಿಡಿಯೋ ಕಂಪ್ಲೀಟ್ ಆಗಿ ರೆಕಾರ್ಡಿಂಗ್.
ಹೌದಾ, ಸರಿ. ನೆಕ್ಸ್ಟ್ ಟಾಪಿಕ್
ನೆಕ್ಸ್ಟ್ ಇನ್ನೊಂದು ಮಾಡೋಣ ಅಂತ ತಡಿ. ಇದರಲ್ಲೇ ಆಗುತ್ತಾ ಇಲ್ಲಪ್ಪ. ಟೈಮ್ ರಿಮೈನಿಂಗ್ ಇನ್ನು 4 ನಿಮಿಷ ಐತಿ.
ಅಲ್ಲ ಜಲ್ದಿ ಮುಗಿಸ್ರೆ.
ಓಕೆ, ಇನ್ನೊಂದು ಇದ್ರಾಗೆ ಮಾಡೋಣ.
ಸರಿ,
ಜಲ್ದಿ ಜಲ್ದಿ ಓದ್ರಿ.
ನೆಕ್ಸ್ಟ್ ಸರ್ಕ್ಯೂಟ್ ಹಾಕು.
ಹಾಕ್ತೀನಿ ತಡಿ.
ದೇವಿಕ ಸ್ವಲ್ಪ
ಸರಿ.
ಜಲ್ದಿ ಓದು.
ಸರಿ.
ಹಾ,
ಕರೆಕ್ಟ್ ಆಗಿ ಕಾಣಿಸ್ತೈತಾ ನಂದು ವಿಡಿಯೋ?
ಕರೆಕ್ಟ್ ಆಗಿ ಕಾಣಿಸ್ತಾ ಐತಿ.
ಸರಿ, ಸ್ಟಾರ್ಟ್ ಮಾಡ್ಲಾ?
ತಡಿ, ಸರ್ಕ್ಯೂಟ್
ಮಾಡು.
ಹಾಕ್ಬೇಕಾ?
ಸರಿ.
ಸರ್ಕ್ಯೂಟ್ ಕಾಣಿಸ್ತಾ ಐತಾ ನಿಮಗೆ
ನಾನ್
ಸ್ಕ್ರೀನ್ ಅಲ್ಲಿ?
ನೋಡಕತ್ತಿಲ್ಲ. ನಾನು ಇದ್ ನೋಡಕತ್ತಿದ್ದೆ, ಇಂಟ್ರಡಕ್ಷನ್ ಅಬ್ಸ್ಟ್ರಾಕ್ಟ್ ಪ್ರಾಬ್ಲಮ್ ಸ್ಟೇಟ್ಮೆಂಟ್ ಅದ್ ನೋಡಕತ್ತಿದ್ದೆ. ಸ್ಟಾರ್ಟ್ ಮಾಡ್ಲಾ?
ಈಗ ಆಯ್ತಲ್ಲ ಇದು ಸಮ್ಮಿಂಗ್ ಅಪ್.
ಇವಾಗ ಸಮ್ಮಿಂಗ್ ಅಪ್.
ಇದು 3 ನಿಮಿಷದಾಗ ಆಗ್ತದ? ಇದನ್ನ ಜಲ್ದಿ ಓದ್ಬೇಕು.
ಬೇಗ ಸುಮ್ನ ಪ್ರಾಬ್ಲಮ್ ಸ್ಟೇಟ್ಮೆಂಟ್ ಬಿಟ್ಬಿಡ್ತೀನಿ, ಆಬ್ಜೆಕ್ಟಿವ್ ಡೈರೆಕ್ಟ್ ಮಾಡ್ಬಿಡ್ತೀನಿ. ಏನಂತೀರಿ?
ಪ್ರಾಬ್ಲಮ್ ಸ್ಟೇಟ್ಮೆಂಟ್ ಬಿಡು, ಬೇಡ ಅದು.
ಸರಿ ತೋ. ಇಂಟ್ರಡಕ್ಷನ್ ಅಬ್ಸ್ಟ್ರಾಕ್ಟ್ ಬೇಡ ಅನ್ಸ್ತದ. ಅಬ್ಸ್ಟ್ರಾಕ್ಟ್ ಬಿಡ್ತೀನಿ, ಪ್ರಾಬ್ಲಮ್ ಸ್ಟೇಟ್ಮೆಂಟ್ ಆಬ್ಜೆಕ್ಟಿವ್ ಹೇಳ್ತೀನಿ. ಯಾಕೆಂದ್ರೆ ಇಂಟ್ರಡಕ್ಷನ್ ಅಬ್ಸ್ಟ್ರಾಕ್ಟ್ ಸೇಮ್ ಇರ್ತದಲ್ಲ, ಅದಕ್ಕ.
ಸರಿ ಆಯ್ತು, ಪಟ್ಟನ್ ಹೇಳು. ಜಲ್ದಿ ಮುಗಿಸು.
ಸರಿ,
ತಡಿ
ಸ್ಟಾರ್ಟ್ ಮಾಡ್ತೀನಿ.
ಇದು ಯಾಕೆ ಹಿಂಗ್ ಆಗ್ತೈತಿ?
ಅಲ್ಲೋ, ಸರ್ಕ್ಯೂಟ್ ಹಾಕಿಯ ನೀನು? ಎಲ್ಇಡಿದ ಹಾಕಿಯ ಇನ್ನು?
ಒಂದ್ ಸೆಕೆಂಡ್ ತಡಿ, ಇಲ್ಲಿ ಓಪನ್ ಆಗ್ತದ ಅನ್ಸ್ತದೆ ಫುಲ್. ಬ್ಯಾಂಕ್ ಇನ್ನೊಂದ್ಸತಿ ಇದೊಂದ್ ಮೀಟಿಂಗ್ ಜಾಯಿನ್ ಆಗ್ತೀರಾ? ಇದು ಯಾಕೋ
ಸರಿ
ಓಕೆ,
ಆಯ್ತು.
ಬಂತು 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 ತಡಿ ಬಂತು.
ಹಾ ಸರಿ ಸರ್.
ಹಾ, ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡು ಜಲ್ದಿ.
ಸರಿ ಸ್ಟಾರ್ಟ್ ಮಾಡ್ಲಾ?
ಹಾ
ಹಾ
ಸ್ಟಾರ್ಟ್ ಮಾಡು.
Hello everyone, I am Devika KS. I am going to explain the summing up of op-amp. Introduction. A differential amplifier is a fundamental building block in analog electronics, especially in measurement and instrumentation applications. Its main function is to amplify the difference between
ತಡಿ, ಒಂದ್
two
ನಿಮಿಷ,
input
ಇದ್ರಲ್ಲಿ ಆಗಲ್ಲ.
signals.
ಇನ್ನು 1 minute ಅಷ್ಟೇ ಇರೋದು. ಇನ್ನೊಂದ್ ಮೀಟಿಂಗ್ ಜಲ್ದಿ ಲಿಂಕ್ ಕ್ರಿಯೇಟ್
ಹೌದಾ?
ಮಾಡ್ತೀನಿ ತಡಿ. ಹಾ
ಸರಿ ತೋ.
Hello everyone. My- Hello everyone. Myself Jagadish. I am concluding about its OPMP and its circuit application. This kind of configuration is frequently used in analog sensor signal confidently where interface must be rejected. Audio, uh, audio, audio electronics to eliminate hum and noise picked by cables. Date accuracy systems requiring precious amplification of small differential signals while ignoring notes. And about conclusion, the simulated differential amplifier circuit demonstrated the principle of common mode rejections, producing almost zero outputs when both inputs are equal. This confirm correct designs and theoretically operation. Such finding the reinforce of the value of differential amplifiers in application, where signal integrate and noise immunity are critical. The experiment highlights of importance of matched resistance and feedback for achievement irreversible performance. And the circuit serve as a excellent foundational example for engineering students entering analog design. Thank you.